Well, welcome back, my friends. We will continue our journey in the language of probability by looking at the language of how we discuss subsets. Sets can be specified in many ways. A set can be finite. Finite means that it has a limit to it. Here is a finite set, and this would be read as S equals the set of all x sub 1, x sub 2, all the way up to x sub n, where n is a countable number. There might be 5x, there might be x1, x2, x3, x4, x5, there might be 100,000 x, but n is a countable number. S equals the set of all x sub 1, x sub 2 up to x sub n, where n is a countable number. A set can also be infinite. Here's a representation of an infinite set. T is equal to the set of x1, x2, on out to x sub infinity. Sets can, of course, be defined by some condition on x. And this is a very common manner of defining a set. Here we have y equals the set of all x such that x satisfies some property. Now this is a new symbol here. Y equals the set of x such that x satisfies some property. Such that is a new symbol to you. Here C equals the set of x such that x is less than 2. This would be an infinite set because there are infinite numbers of x that are less than 2. We have another way of writing a set. D equals the set of x such that x lies between 0 and 12. 0 is less than equal to x is less than equal to 12. And this is a continuous range of values because there's no discontinuity between 0 and 12, and this is an uncountable set. In other words, there are so many values between 0 and 12. There's square root of 7, there's pi, there's e. I mean, those numbers are between 0 and 12, and they're not only an infinite set, but they're an Aleph 1 infinity. Looking at subsets is one of the things that we want to do. Now here we have a set G composed of the elements 2 and 4, and we have a set H composed of the elements 1, 2, 3, and 4. G is a subset of H. G is a subset of H if every element of G is also in H. And this would be written in this manner. G is a subset of H, and it is read as G is a subset of H. This symbol means subset. G is a subset. Subset means that every element in G is also found in H. Now let's look at some other things here. C is not a subset of H if every element of C is not in H. If you'll notice, set C is 2, 4, and 5. Set H is 1, 2, 3, and 4. The element 2 is in H, the element 4 is in H, but the element 5 is not in H. So C is not a subset of H. Now here's how you write that in symbols. C is not a subset of H. This is read as C is not a subset of H. You have to learn to speak the language. More ways of saying things. Isn't this impressive? This reads that G is a subset of H if and only if. The if and only if statement symbol means that if this is true, this is also true. And it means that if this is true, then it goes back the other way that that is true. G is a subset of H if and only if X is an element of G implies that X is also an element of H. In other words, 2 is an element of G. That implies that 2 is an element of H. 4 is an element of G, implies that 4 is an element of H. That's read that G is a subset of H if and only if X, an element of G, implies that X is an element of H. How about that? You're catching on to these symbols. Now let's learn even more ways of writing that. G is an element of H if and only if for every X an element of G, it implies that X is an element of H. Here's you another symbol. This means for every X an element of G, means that that X is an element of H. This gets pretty intense, doesn't it? It's read as G is a subset of H if and only if for every X an element of G implies that X is an element of H. For the following, F is the subset or the set of 2, 4, and 5. H is the set of 1, 2, 3, and 4. Now what F is not a subset of H, and it's read as F is not a subset of H. So another way of saying that is F is not a subset of H if and only if, now here's a new symbol, there exists an X such that this X is an element of F and this X is not an element of H. Now look at those symbols. We'd read that again. F is not a subset of H if and only if there exists an X, an element such that X is an element of F and X is not an element of H. Here's a 5 that is an element of F, and this 5 is not an element of H, which means that F is not a subset of H. Simply put, there's an element in F that is not in H, but you need to be able to read these symbols, and you're getting there. F is not a subset of H if and only if there exists an X such that X is an element of F and X is not an element of H. It's pretty cool, pretty cool. Here we have G and we have H. G is a proper subset of H. Now it can be a subset, but anything is a subset of itself. G is a proper subset of H if every element in G is in H and there is at least one element in H that is not in G. That's read this way. G is a proper subset of H. This symbol means proper subset. More ways of saying things. Oh my gracious, doesn't it get fun? G is a proper subset of H if and only if every X, an element of G, implies that it's in X as an element of H. So if every one of these is in H and there exists some X, right here's one, an element of H such that that X is not an element of G. So all that says is everything in G is found in H, but there's something in H that is not in G. This is pretty cool. Let's read this again. Here we go. G is a proper subset of H if and only if for every X, an element of G implies that X is an element of H, and there exists some X, an element of H, such that X is not an element of G. You're learning to read some powerful symbols. You're getting there. Just look at this statement. Wow, you can read this. That's pretty impressive. Now, two sets are said to be equal sets if they have the same elements. And the way you would write that symbolically, S is a subset of T, and T is a subset of S. So if S is a subset of T and T is a subset of S, then that implies that S equals T. Two sets are equal if they have the same elements. And the only way that they can have exactly the same elements is the first to be a subset of the second and the second to be a subset of the first. This is read as S is a subset of T and T is a subset of S implies that S equals T. This imply symbol can also be read as an if-then statement. This statement says that if this is true, then this is true. Some of the symbols you need to know from this lecture. This symbol is a such that symbol. This symbol is infinity. This symbol is a subset. This symbol means that it's not a subset. This is for every. This is there exist. This is such that. This is if and only if. And this implies an if-then statement. If this, then that, or this implies the other. Some of the terms you should know. Subset. Proper subset. What's the difference between a subset and a proper subset? Well, a subset says that everything in the first set is in the second set. So something can be a subset of itself. They have exactly the same elements, therefore they're subsets of each other. Proper subset means that there's something in all the elements of the first set are in the second set, but there's something in the second set that is not in the first set. Equal sets, that means that they equal each other. They have the same elements exactly. Again, I want to thank you very much for your support. May the odds be ever in your favor unless we're in the same competition. Then it's every man for himself. I hope you've enjoyed these videos. They're brought to you from the AURAC Teaching and Learning Center in Ras Al Khaimah in the United Arab Emirates.